5.3, solving trigonometric equations. We're first going to verify that an x value works for a particular equation. Number 2, secant of x minus 2 equals 0. We'll plug in pi over 3 for x and see if that's true. So that would be, solve it for secant of pi over 3. And I can rewrite secant as 1 over cosine, right? So 1 over the cosine of pi over 3 equals 2. So we can put this over 2 over 1 and flip, if I flip the left side and flip the right side, so I can get cosine of pi over 3 is equal to 1/2. And is cosine of pi over 3 equal to 1/2? Yes. So that works. So let's try 5 pi over 3. So secant, actually instead of plugging this in, we can plug it into the end part. Now I'll go ahead and work it. Secant of 5 pi over 3 minus 2 is equal to 0. It would be 1 over cosine of 5 pi over 3 is equal to 2. And flip that, cosine of 5 pi over 3 is equal to 1/2. If you look on your unit circle, you will see that cosine of 5 pi over 3 is equal to 1/2, so both work. Okay. Next, we'll solve the equation. So to solve the equation, you want to isolate the variable. So we have, on number 8 here, we want to subtract 1 from both sides. So 2 sine of x is equal to -1, divide by 2. Sine of x is equal to -1/2. And you can solve that for x. I said isolate the variable. You can get, you can do x equals sine inverse of -1/2, or leave it the way it is and say that x is equal to wherever you have -1/2 for sine, which is at 7 pi over 6 Okay, I need to stop for a minute and explain something. So first thing we need to do is find all the solutions in the interval from 0 to 2 pi. So 7 pi over 6 and 11 pi over 6 would be from 0 to 2 pi. But because sine of x has a period of 2 pi, the solutions are 5 pi over 4 and 7 pi over 4. We have to add multiples of 2 pi to each of these solutions to get the general form. We would add 2 in pi. So if I go to 7 pi over 6 and I go one more revolution, that would be another solution, and go another revolution. I could go into an infinity, and so to account for that, you have to add 2 in pi. So what does that mean? If I plug 0 in for n, I get 7 pi over 6. If I plug 1 in for n, I get 7 pi over 6 plus 2 pi. If I plug 2 in for n, I get 7 pi over 6 plus 4 pi. So that counts for all of your solutions where it would land at 7 pi over 6 to infinity. So then you would do the same thing for 11 pi over 6. So that would be all solutions for number 8. Number 10. Subtract root 3 from both sides. So tangent of x is equal to negative root 3. And tangent of x is equal to negative root 3 at 2 pi over 3. And 5 pi over 3. Okay. Here's the thing about tangent. It's a little bit different. So we have a period for tangent. If you'll remember, whenever you learned how to graph tangent, your period was 0 to pi. So instead of adding 2 in pi, because that's what we have for sine and cosine, we're adding pi. So it'd be in pi. N would be your integer. So if I plug in 0, I have 2 pi over 3. If I plug in 1, I have 2 pi over 3 plus pi. Well, 2 pi over 3 plus pi happens to be 5 pi over 3. So since 5 pi over 3 would be pi away, I actually do not have to write down 5 pi over 3. It would be redundant. 2 pi over 3 plus n pi would cover all of my answers for tangent. Okay, number 12, we will add 1 to both sides. So we have 3 cotangent squared x is equal to 1. Divide both sides by 3. Cotangent squared x is equal to 1/3. Then we have to take the square root of both sides. So cotangent of x is equal to plus or minus the square root of 1/3. What we want, or what I want, is tangent. 1 over tangent x is equal to plus or minus the square root of 1/3, and which, by the way, is plus or minus 1 over the square root of 3. So I could rewrite that as the tangent of x is equal to plus or minus root 3. So x is equal to, we have two answers, positive root 3 and negative root 3. So for positive root 3, we have pi over 3. So for root 3, we have pi over 3, and that would be plus n pi, which you'll see also includes the 4 pi over 3. So we don't have to write 4 pi over 3 for the two answers that are on the unit circle for root 3. We also have, for negative root 3, we have 2 pi over 3. And that would be plus n pi, and that would also cover your answer for 5 pi over 3. Number 18. Okay, this one's a little bit different because we have 3x instead of just x. For this one, we're going to treat 3x like it's the angle. So we'll solve for tangent of 3x. So we have to take the square root of the other side, or square root of both sides. So the tangent of 3x is equal to plus or minus the square root of 3. So you want to see where is tangent of some angle, will let be 3x, equal to root 3, positive root 3. Okay. So positive root 3 for tangent would be pi over 3 plus n pi. And look on your unit circle and see that for root 3, tangent of some angle, which is for this particular problem, 3x, is pi over 3 plus n pi. So, you know, we're having to do it this way because you cannot divide by 3 before you get rid of the tangent, do the inverse of tangent. Now that we have found the inverse tangent of root 3, we can divide by 3. So that means we divide everything by 3. So x is equal to pi over 9 plus n pi over 3. Okay? That takes care of all of our answers. For positive root 3, now we have to work with 3x equals, it's a negative root 3, which is 2 pi over 3 plus n pi, and divide everything by 3. So x is equal to 2 pi over 9 plus n pi over 3. Okay, for number 20, this is something that has already been factored for us. So in a minute, we'll have a problem where we have to factor. But for this one, it's already factored. So you set each factor equal to 0. Similar to, let's say you have, let's just say you have 2x times y. Well, it's not a good example. So remember when you factored in, let's say you have x plus 1 and x minus 1 equals 0. You set each factor equal to 0. Well, similar to what we're doing here on number 20. We have two factors. We're setting each factor equal to 0. So cosine of 2x equals 0. 2 cosine x minus 1 equals 0. So here the cosine 2x equals 0. 2x is equal to, you're going to treat 2x like it's the angle theta. So where is cosine of theta equal to 0? At pi over 2. And that's plus. Okay, this one can be a little tricky. Cosine of 0 is at pi over 2 and at 3 pi over 2, which means it repeated after half of a revolution. So instead of saying plus 2 in pi, you could actually put plus in pi, and that would include your pi over 2 and your 3 pi over 2 answers. So divide by 2. So x is equal to pi over 4 plus n pi over 2. That covers cosine of 2x equaling 0. For 2 cosine x minus 1 equals 0, we'll add 1 and divide by 2. So cosine of x is equal to 1/2. So cosine of x, where is cosine 1/2? Cosine of the angle is 1/2 at pi over 3. And that would be plus 2n pi, and then 5 pi over 3 plus 2n pi. So let's compare and contrast here. Y, on the left-hand side, we have plus n pi in the beginning, and on the right-hand side, plus 2n pi. So when your two answers for the one on the left, you're repeating after half a revolution. But your two answers, pi over 3 and 5 pi over 3, for the one on the right, the 2 cosine x minus 1 equals 0, you have, that's not half of a revolution or a whole revolution or anything like that. So it would be hard to include that into the 2 and pi. So you have to do them separately. Now, I don't know about your teacher, but if you were to do the first part separately, the pi over 2 plus n pi and the 3 pi over 2 plus n pi, I don't see where that would be wrong. It would just be redundant. Number 22. Secant squared x is equal to 1 when you add 1 to both sides. Secant of x is equal to plus or minus the square root of 1, which is 1. Okay, so secant is 1 over cosine x. And if I want to get cosine x, if I want to flip that and get cosine x instead of 1 over cosine x, what is the reciprocal of 1 or negative 1? 1 or negative 1. So x is equal to, cosine is 1 at 0. Okay, now look at the top. Find all solutions of the equation in the interval from 0 to 2 pi. So I don't have to include the plus 2 and pi. That makes this problem easier to work. So cosine is positive 1 at 0 and negative 1 at pi. So that would be your 2 answers. Find all solutions of the equation in the interval from 0 to 2 pi. You want to see that so that you don't have to do the plus 2 and pi or plus n pi. So for this one, you'll need to use your identities because we have sine squared x and we have cosine x. So what the best thing to do would be to change sine squared x to 1 minus cosine squared x. If you'll look on your look at your Pythagorean identities, you'll see where you can do that. So that would then you would distribute, because by changing it to cosine, you'll see that you have a quadratic cosine. A quadratic term, a linear term. So cosine squared x, cosine x, and we should be able to factor this. So 2 minus 2 cosine squared x is equal to 2 plus cosine x. Get everything on one side. I would subtract 2 and add 2 cosine squared x. 0 equals 2 cosine squared x plus cosine x. And when you subtract 2, the 2's go away. So 0 is equal to, we can factor out a cosine. And you're left with 2 cosine x plus 1. Set each factor equal to 0. Cosine of x equals 0. 2 cosine x plus 1 equals 0. Cosine of x equals negative 1/2. So cosine of x equals 0 at x would be pi over 2, 3 pi over 2. We go ahead and just add our numbers to that. Where it's negative 1/2 would be 2 pi over 3 and 4 pi over 3. Okay, so here you're going to have to factor. We have quadratic term, linear term. So we need factors of 2 sine squared x and 1 that some combination will give you positive 3 in the middle when you do outer and inner. So luckily for us, the 2 only has 2 sine x and sine x. And factors of 1 and 1. There's a plus in front of 1, that means the signs are the same, and there's a plus in front of 3, that means they're both positive. We can check first, outer, inner, last. 2 sine x times sine x is 2 sine x squared. And outer and inner, outer would be 2 sine x, inner would be 1 sine x for a total of 3 sine x for the middle term, and then 1 times 1 is 1. So that works, that checks out. 2 sine x plus 1 equals 0. Sine x plus 1 equals 0. Sine of x is equal to negative 1/2. And, whoops, I forgot my x there. Sine of x is equal to negative 1. So where is sine of x? Negative 1/2. And that'd be 7 pi over 6. 11 pi over 6. And for negative 1, we have 3 pi over 2. Okay, that works. Okay, so here we have 2x is equal to, where is sine of an angle, negative root 3 over 2? That would be at 4 pi over 3. And we have to add 2 and pi. I'll go ahead and put the other answer in here. 5 over 3 plus 2 and pi. Sometimes I like to do that at the same time and then divide by 2. So this is x is equal to 4 pi over 6. Let's see. I can actually reduce the 2 and the 4. So 4, that's okay. 4 pi over 6 plus n pi, which is 2 pi over 3 plus n pi. So x for this one will be 5 pi over 6